What I want to do in this short screencast, which is the last of all the videos for this chapter, I want to discuss the types of solids and just basic properties as to how we classify them. So mainly there are going to be 4 kinds of solids, and so from this aspect of the chapter, I want you to just focus on what I'm going to discuss, not the crystal lattice and all of that good stuff. Like I said, there are 4 kinds of solids. We have the ionic solids, we have the covalent solids. Sometimes these are also referred to as molecular solids. We have the metallic solids, and we have what are called as covalent network solids. Ionic solids, as the word itself suggests, these are those solids that would be formed due to the presence of ions. That means there would be a positive cation and there would be a negative anion, and together they would form a crystalline lattice. Now, one thing which is pretty characteristic about these lattices is that when you have them as solid, they do not conduct electricity because the ions are bound, they are not free floating. But when you add water, so in aqueous solutions, when you put water as aqueous solutions, these will conduct. Good conductors of electricity, but only as aqueous solutions or sometimes in molten forms. But understand that because you have the presence of ions, these are Coulombic forces of interaction, which are very strong. And so what that means is that the melting point and the boiling point of ionic solids are going to be pretty high. Just to give you a flavor, sodium chloride melts at 800 degrees Celsius or so. And if you think about magnesium oxide, that melts close to about 3000 degrees Celsius. And the reason that MgO melts at such a high temperature is because you have essentially Mg2 plus and O2 negative, and since these are Coulombic forces of interaction, essentially those forces are directly proportional to the product of the charges. And so hopefully you can envision that you have 2 positive and 2 negative charges. So essentially these forces are going to be 4 times as strong as what you would see in case of sodium chloride. And since the forces of interaction are going to be stronger, that is the reason why the melting point is going to be strong as well. I want you to think about covalent or molecular compounds. These are discrete molecules. So you will see the kind of interactions in, let's say, H2O or CO2. So depending on the polarity, the melting point and boiling point are going to be variable. The melting point and boiling point, they are going to be variable. Just to give you a reference point, water boils at 100 degrees Celsius. On the other hand, CO2 is present as a gas at room temperature. So the melting point and boiling point, I would say, are variable, but they are still lower as compared to ionic compounds. These are not going to be conductors of electricity. They are bad conductors of electricity. But since these are discrete molecules, A lot actually will depend on the intermolecular forces of interaction that are present in these kind of solids. Now, when you think about metallic solids, those would be present in metals. So if you think about iron, but also realize mercury, which is a liquid, is also a metal, and so is gallium, which melts on your palm, because the melting point is like 29 degrees Celsius. And so if you place it on your palm, your body heat is enough energy which will convert solid gallium to liquid gallium. So again, the forces of interaction here are going to be variable. So the melting point and the boiling point are going to be variable as well. But being metallic, they will always conduct electricity. Of course, they will have a shine associated with them. Not necessarily hard, because again, mercury and gallium, those will be soft. In fact, copper that can be drawn into wires, or sodium that can be cut with a knife. So hard or soft, that is that is pretty variable in this case, variable hardness. For ionic, we can say that these in general will be crystalline, and so hard but brittle. So they break. And of course, since there is crystal, it might have a luster, a shine associated, or a color associated with it. So that part is variable. Covalent molecules, these are usually gases or amorphous solid. Amorphous solid. Amorphous means that there's no specific shape associated. So think about dry ice, think about ice, think about sulfur, I say chains. Those are all covalent bond containing compounds. The last one here is the covalent network solid, which essentially has multiple atoms, such as, many carbons connected to other carbons in a three-dimensional space, such as in case of diamond. So covalent network is different than covalent or molecular compounds, because here the covalent compounds are going to extend in a three-dimensional space, and since it's a network, there are too many very strong covalent bonds. Because of that reason, these have very high melting points and boiling points, usually to the tune of 3000 degrees Celsius or so. But these are always bad conductors of electricity. Bad conductors of electricity. So if somebody asks you, how would you classify a solid which is hard and is a good conductor of electricity in solution? That is an ionic compound. On the other hand, if we say that it has high boiling point, but is a bad conductor of electricity at all times, that would be a covalent network solid. So realize melting point of both ionic and covalent network is high. Melting point of molecular and metallic, those are variable. But only metallic and ionic are the ones which have the capacity to show some kind of conductance to electricity. In case of metallic, it's all the time. In case of ionic compounds, only when you put it in water so that the free ions get generated. So based on their properties, you should be able to classify solids into one of these four classes.